Hi, this is Jason Radford, and today I'm going to talk to you about designing multi-person studies. This is the second to last workshop in our summer series. The last one is going to be about building your own subject pool. So, recruiting volunteers, engaging them over the long haul for longitudinal studies, or just having a pool of subjects to send your next study invitation out to. You can register for that workshop at volunteerscience.com/events. We're going to host a series this fall as well. So check back to volunteerscience.com/events for an announcement regarding when and what we're going to cover this fall. If you have ideas for what you would like to see in our workshops this fall or in the future, please go to allorideas.org/vs-trainings, and we will take your ideas there. You can vote on other people's ideas, submit your own, but that's where we're going to be looking for our next set of inspiration for future workshops. All right, on with the show. So today, we're talking about designing multi-person studies online specifically. So the first thing we're going to talk about is just types of multi-person studies. This is meant to be sort of generative for you to think about the different kinds of things that you can do online if you were trying to do multi-person real-time interaction. Next, we're going to talk about how multi-person studies work. We're going to get into the engineering of it, and we're going to stay at a high level. We're not going to get into the details of the specific kinds of code you would write, but we're just going to think in the abstract. How do you make sure that everyone who is participating in your study has the right data at the right time? Third, we're going to talk about design considerations. These are going to be the best practices that we've learned running volunteer science, doing multi-person studies. Some of these are technical design considerations. Some of these are more scientific considerations. And lastly, we'll talk about recruiting participants. The all-important, how do I get people to show up at the same time for this study? So let's start off with the types of multi-person experiments. Now, there are some classic multi-person studies. So microeconomics has given us a whole bevy of interpersonal bargaining, negotiations, and dilemma games like Prisoner's Dilemma, Public Goods Game, the Commons Game. These involve usually one or two or smaller groups, 3 or 4 groups, dealing with making choices that affect one another. So with the Prisoner's Dilemma game, you're deciding whether to cooperate or defect on another member with a certain payoff, or if both of you cooperate or both of you defect or one of you cooperates. Next, we have sort of a macroeconomics experimental framework, which is simulated markets. And here you have larger groups of subjects, so it can be as small as 3 or 4 or 5, but you can also get to 10 and 20 and 30. People participating in simulated auctions, creating pricing bubbles, and working in markets with more or less degrees of monopoly. Lastly, in the IO psychology, industrial organizational psychology, group psychology literature, we have teams research. So typically small, 3, 4, 5-person teams, but sometimes larger, where the individual team members are trying to solve a problem or make a decision or act collectively or solve a conflict. So some team members want A, some want B, and how do they decide A or B? There are a couple of new classics that have emerged over the past 10 to 20 years. These are all relatively old. They're not completely unheard of, but these are more common now. So one is the network experiment, where you have a group of people. These can be small or large, but you control who sees whom or who can interact with whom. So not everybody can see everybody else or talk to everybody else, but they can talk to a certain set of people. In these cases, you just create a social network and then have them solve problems, whether they're team problems, economic problems, little puzzles, what have you. After that is teams of teams. So this is really taking advantage of the fact that you can create really large online experiments using the internet and web capacities. So you have one team that is assigned to do one task, another team assigned to do another task, and then a team in the middle that's assigned to moderate between the two. That's one example. But the idea here is that each team can collaborate as a whole unit, but then they're interacting either as one member interacts with another team or some subset of members interact with other teams to share information or solve complex problems. And lastly, this is utilizing the crowd. So much like the market experiments, except you're solving different kinds of problems or having them do different kinds of collective behaviors. So these can be simulated voting and simulated elections, reviews and ratings, so having them review songs, for example, in Matt Salganik's famous paper now. You have the crowd just reviewing different things and seeing how the reviews emerge over time. And lastly, collective intelligence, having people in crowds predict the likelihood of future events and other kinds of collective inferences. Now, I want to also mention one other type of multi-person study that doesn't get a lot of focus. And these are actually qualitative studies. So you can do interviews online, and as a researcher interacting in real time with another subject. This is a multi-person study, online study. Same thing with focus groups and field observation. If you are watching people have a discussion, or you're watching somebody browse their computer online and you're online as well, you're doing a multi-person online study. And this research really speaks to how you would engineer or design that kind of study. Okay, so if you want to take a minute, what kind of study you have in mind? One of the things that we like to do is think of, we have a network study. What would this network study look like if we were trying to work on a market problem? So if there's a monopoly, but the underlying social structure is a network rather than a free-for-all market. So take some time now if you would like to think about the kind of study that you want to do. In the meantime, we'll move on. Feel free to pause the video. So this section of the study or the presentation is about just the engineering design of this kind of experiment. The question is, how do you make sure everybody has the right data at the right time? This is called the steady state or game state. A lot of the language here is developed for multi-person online games. So I'll talk about game state frequently. So what's happening when you're doing a multi-person study is participants are on their local machines, and as they do something with your study, that data gets sent to the server. And then, it hits the server, and then it goes out to everybody else. The question that you have to answer for yourself, and the answer will depend on the technology that you have, is where do I put the code for this integration so that I know that player 1 has player 1's data, player 2 has player 2's data, and that when player 3 needs data from 1 through 6, players 1 through 6, that they have all of that data. So the first typical solution here is a server-to-all solution. And in this case, the server is doing all of the work of coordinating the information and making sure that player 1, player 2, player 3 have the information that they need and that the study is coherent. That when player 1 says hello, everybody sees hello show up in their chat. So in this case, the server is doing all the work. They're maintaining what round we're in, who's where in the network, who said what to whom. The server is keeping track of the whole thing. The way that the information flows is the player makes their move and it gets sent to the server. The server updates the steady state. So player 1 says hello, and then server says, here's the entire chat. Right now it's just player 1 saying hello. And then the server will send that chat information to everybody else. The strengths here is that it scales well within the study. You can get a pretty large server with lots of individuals participating in it. Most websites work are basically this, right? A website is just sitting on a server and sending that data to individuals. The other advantage of using this approach is that it can work in many programming languages. So if you're working in Python or you're working in R, you can do that on a server. And it's not necessarily true that you can do that in a browser. Actually, you can't do it in the browser. Of the existing platforms out there, I believe O-Tree is the one that works this way. O-Tree is a Python library. It sits on the server. Everything operates on the server. And it updates. The game state is maintained in the core server files. The weakness here is that it doesn't scale well across studies. So you can have a group of up to 100 people in a particular study, but you really would not want to do 2 or 3 or 4 groups of 100. The server would melt down pretty quickly. You can get bigger and bigger servers, but there's really a fundamental limit to the number of people that you can get on a single server. So the idea here is that if you wanted to do 4 or 5 or 10 or 20, you would need to spawn new servers to continue to scale. And you would need a pretty big server to work with a game of 100. Oh, and it's the other sort of weakness to the solution one is that it's not the most secure version of this particular solution because people are able to run code on your server. And so if you have a server that has other people's data on it or other experiments going on it, people can get access to that server and hack it a little bit easier than the next one here, which is the all-to-all solution. And the all-to-all solution, each person actually maintains the current study information, the current round, who talks to who said what. The way this works is player one, for example, again, says hello. That message gets sent to the server, and the server immediately passes it to everybody else. And then each person makes that update on their system. The code that an individual has, what's called the client code, as opposed to the server code, will update their local chat interface. So player 4's local chat interface will say, oh, hello. And it just so happens that everybody else is going to see the same thing. The strength here is that it scales well across studies. So when individual people are making the updates, or when people's machines are the ones who are updating the game state and maintaining it, it takes all of the load off of the server. So the server is not doing any of that stuff. The only thing the server is doing is just passing data around to every other player. The other strength here is that it's more secure, so there's no code being run on the server, no code executed on the server. It's just the server is just acting as a pass-through. The downside here is that people will receive messages in different orders. So somebody can have a weak connection, and player one can say hello, and that gets to player 4, but player 2 says hi, and that gets to player 3 before player 1's message gets to player 3. So you can get messages out of order when you're doing an all-to-all system. So you want to make sure when you're writing your integration code that you take into account that you may not necessarily get messages in the same order across everybody in the study. Another weakness here is that it only works in browser readable languages, which for all intents and purposes means JavaScript. There are other languages, but JavaScript is really the basic language. It's very well supported, very well documented. It's hard to imagine doing something other than JavaScript in a browser. But that means you have to learn JavaScript to do this. Lastly, it's more computationally intensive. So rather than having one game state maintained by one piece of code, it has to be updated by everybody. So you're having 4 machines do the same processing if you have 4 people in your study. The other thing with the computational intensiveness is that if you have a bug, it may show up differently on different people's devices. So going back to this receiving messages out of order, everybody gets the messages in the expected order that you get them, but then there's one person doesn't, and so you have to be aware that when you're debugging, you may not see player 3's screen may be different from everybody else's because of this as a part of the debugging process. So the solution to this sort of level of complexity is using one-to-all. And what this does is it will, so player 1 sends a message. That message will go to everybody, but the sort of core person who you have assigned to be the game state keeper will be the one to update the information and then send the updated information to everyone else. So what this does is it increases the amount of communication that's going through the server. So you're sending twice as many messages, basically, because the server receives that initial hello, sends it out to everybody else. The player who's keeping track of the game state updates the game state and sends it back to the server and updates everybody else. And then everybody then updates their individual game state with the new information. So you're doubling the amount of data that's being sent around. But you only have to use one person to maintain the core game state. So it's more computationally simple to keep track of that. Again, you're still scaling well across studies. It still has that security. And it reduces the communication load because you don't have to worry about player 3 or player 4 having different interfaces. Again, it doesn't. It only works in JavaScript and it's still computationally intensive because of all of the messages that get sent. Yeah. Okay. So I should mention. So solution 2.5 and 2 and 2.5 are what volunteer science uses. So if and I think empirically, I think uses this, though you may have the choice. So the systems that you have available, volunteer science uses solution 2.2 or 2 and 2.5 because it scales across studies and is more secure. Okay, so just keep in mind which approach you think you'll use. It's just helpful to have that high-level understanding of how you're going to update the game state as information gets sent from player to player. Okay, now let's talk about design considerations. What should you be thinking about? How should you be thinking about the different pieces of your study and what goes in what order? So the first thing to talk about is just a basic binary decision that you'll have to make, and that's about how you'll send information to people. So there are two basic protocols, UDP and TCP. And UDP is what we use for streaming video, basically. It's you're sending lots and lots of data, so it's fast. But the trade-off is that it's lossy. So you lose data, packets get dropped, basically, if the connection gets weak. So in the example here, we have a video game where on the left-hand side is very clear, and on the right-hand side is very pixelated. This is UDP. So if you want, it's really good for audio video streaming. So if you wanted to do a study where you're streaming somebody's video to everybody else, you'll use UDP. But also if you're doing real-time movement. So if you have people moving in a space in real time together, you'll use UDP. On the other side is TCP. So it's zero loss, but it's slower. Now, when I say slower, it's 100 milliseconds. It's not tens of seconds or even single seconds usually. Most of our experiments, all the data gets sent around to everybody within a second. 2 seconds if we're slow. So that's what we mean by slower. The types of TCP here are HTTP, so you have a basic HTTP support for sending TCP messages. But there's other technologies here. WebSockets is I would say it's still the standard. It's faster and more scalable than HTTP. It's been around forever, or at least the last 10 years, forever in tech terms. The new standards are WebRTC, and now there's QUIC, QUIC. WebRTC is more established and more commonly used now, but it's still a little less supported, less documented than something like WebSockets. QUIC is the bleeding edge. QUIC is very quick and zero loss, but it's still not quite as well supported as the others. So your mileage may vary if you build with QUIC. And the strengths of TCP is that it's good for things like chat, turn-based studies, and co-editing. So as long as you want to make sure that there's zero loss in your data, you don't want to have people's messages get lost, or you don't want to have individual letters or individual choices get lost. You use TCP. And I'd say in our experience, we use TCP 95% of the time. Like say it's zero loss and it's a little bit slower, but in terms of human cognition and human decision making, it's completely fine in terms of latency. Okay, lots of logistical design considerations here. Because I know this is a video being recorded, you can pause the screen and really go through this. I'm going to highlight some of the most important ones. So the first thing that if you have the ability to make this work in your study, you should, is to allow for a flexible number of participants. Not only when you start a study, so you can start a study with 3, 4, or 5, for example, or 10, 11, 12, 13. If you give yourself that flexibility, you're going to have a lot easier time recruiting and tolerating attrition than if you can only allow for a very specific number of participants. If you have a very specific number of participants, then that means that as soon as somebody drops, and people drop all the time in multi-person studies, your study is rendered relatively useless. And you're going to lose a lot of data. So as you're designing your study, do what you can to allow for a flexible number of participants. The next consideration is what do you do when participants drop? So people are going to drop either because their connection goes down, or their computer dies, or because they just don't like doing this group experiment. They have a bad time. It's just going to happen, and it happens much more frequently in group experiments than in individual experiments. So what do you do when that happens? So you have four choices. You can end the study, which in many ways is the most humane thing to do if you can't use the data. Don't waste people's time. The next thing that you can do is adding a bot. So you're just programming, as I mentioned earlier here, you have somebody, whether it's a server or an individual, updating the game state. The only thing that you need to do to create a bot is have that person calculate what the bot would do. So having the server, for example, say, okay, everybody's made the decision to defect. We're doing a bargaining experiment or a coordination experiment. And the bot is going to be, flipping a coin, and it's going to randomly select defect or cooperate. And so the server will flip the coin and say, oh, the bot said to defect. And so it'll update the game state and tell everybody that, oh, the bot defected, game lost. So that's the option for adding a bot. You can add another participant. So this is what we call late joining. So if somebody drops, you just bring somebody else in. This is really complicated to do because they have to be ready to participate, and you have to be able to catch them up. But if you have a really long study where it's very easy for people to be added in later, for example, like rating stories or rating videos or making trades, where it's easy to just bring somebody in and have them participate, then this is a good option. The last thing is to go on without them. So again, if you have a flexible number of participants and you don't necessarily need 10 to finish the study, just having that person drop and the other 9 people continue is the easiest thing to do. Related to this is participants who stop responding. So again, people lag out. They have to go to the bathroom. Like, things happen. And when you're having live multi-person studies, people rely on the responsiveness of their fellow members, their fellow participants. So there's a couple of things that you can do. The first thing is, and we recommend this for everything, is having an auto advanced feature. So everything that we do in our experiments is timed. So you get, say, 60 seconds to do the instructions, 60 seconds to make a decision, or 20 seconds really to make a decision. And 20 seconds to see the results. And if you don't press the "Okay, I'm ready" button, we're just going to auto advance you, so that you don't take up too much of everybody else's time. And we'll, if we auto advance on a decision making round, we will automatically make a decision for you, or we will treat you as having not made a decision as we auto advance. The next thing you can do is auto drop. So if somebody is just not participating and it's been 2 minutes since you've heard from them, just treating them as if they had dropped is a good idea. Again, this is why you would have a protocol in place for somebody drops. The last thing you can do is direct communication. So very frequently, especially in multi-person studies, you reach this really odd edge case and the study dies, or there's a bug, or they just don't understand what's going on. So the ability to reach out to them directly, either through text messages, if they're students that you have contact with, or using the message chat system that Volunteer Science has to reach out to individual participants to see what's going on, is another thing that you can do. The issue with direct communication, though, is that you have to be there, watching these participants, as the data are coming in, to see that somebody's not participating. But then you can poke them and see what's going on, and that gives a lot of transparency to the study. I think the other thing that you can do that is the biggest help for recruiting participants and getting high quality data is replayability. So how many times can somebody participate? I mean, usually this is once. Some problems can only be solved once. You can only have one version of the puzzle to be solved. And so there's a lot of learning gains that happen that can spoil a study. But if you can have people participate more than once, you save yourself a lot of time and headache in terms of training, instructions, and recruiting groups. The recruitment side of group experiments is the hardest part. The engineering stuff is easy compared to the subject recruitment. So this replayability component is really helpful if you can design a study that can allow it to be replayed, redone, retaken. These next two, when do you group people and when do you survey and when do you do the randomization, all have to do with a set of trade-offs that you have about when people are likely to drop and where bias is going to occur in your study design. So we know that when people participate in surveys, they can be primed. They can be primed to think of certain things. So if you ask people their race and gender and then have them make decisions about who to hire, they can be primed to think about race and gender and making those hiring decisions independent of whatever treatment that you're giving in that particular study. And so generally the best practice is to do these kinds of demographic surveys or surveys that could prime people after your experimental treatment. The downside, however, to doing that is that attrition creates its own problems, its own biases. And the longer a study goes, the more likely subjects are to attrit. That's just basic math. Over time, you're going to see more attrition. So the question that you'll have to answer for yourself about when to do these demographic surveys and other screening surveys and informational surveys that you'll use for sort of secondary analysis is when do you do them? And your answer is going to be based on what you think is going to be worse, the bias caused by the screeners or the bias caused by attrition. And that's just going to be a substantive question that you have to answer for yourself based on your knowledge of the study. Related to this is when you should randomize, and this also has to do with attrition and participants persisting. So if you randomize at the very beginning of the study when people start taking the surveys, then you're much more likely to get people to attrit early. And so, say you have a group of 10 at the beginning, by the time the first survey is over, you may only have 8 left. And so you end up with fewer people in that particular condition because they were grouped longer. The ideal is to do have people do the surveys and screeners individually, and then they go to the waiting room and you collect them up into groups of 10 or 20 or however many you need, and then do the randomization. That way, by the time you do the randomization, you've eliminated a lot of the attrition up front, and you've minimized the amount of time people are participating in the study after randomization. Last thing to consider is just the interface. Two basic questions. Does it need to be mobile, and how scalable is it? The scalable question is really about, here's the best question is, how is this going to look when you have 10 people all on mobile phones? If you can design for 10 participants on mobile phones, you can have your experiment work for anyone in any device. So a couple of recommendations here is to use Bootstrap, which is a library or a CSS library for making mobile-friendly, or what we call scaling-friendly interfaces, and then using tabs. So having parts of your website that are able to open up and close up, open up, close up. And I don't mean like tabs in like Firefox or Mozilla tabs, but little buttons that you can press on your screen that will open up parts of the study. So one tab for the problem being solved, one tab for the chat, for example. One last thing, and this will become a little more obvious in a minute, but always have a usable one-player version of your study. So either having people participate with a bot or having them solve the puzzle by themselves as a single player is going to do a couple of really nice things for you. I'll show you what that means in a little bit. So I want to stop here for a second and talk specifically to the people who have a hard study design. And what I mean by hard study design is that you have to have a certain number of people. You can't, it has to be 5. It can't be 4, and it can't be 6. And you can't have any people dropping. So not only do you have to start with 5, but 5 have to finish. Now, this is a hard study design. It's not impossible. You just made your life really hard for yourself. So a couple of design recommendations. One, your design goal should be to end the study as quickly as possible and before randomization. The idea here is that you want to get people who are going to drop as quickly as possible, so you can have everyone else either not become non-naive. So if somebody drops in the survey stage, that's fine. You can have those people who are who didn't drop, start another study, go through the survey again, and then do the task. Or you don't want people to waste their time. So you want people to drop early, and if they drop, then the study's over. You don't want people to just spend 10, 20 minutes creating data that you're not going to be able to use. And in this case, you want to prioritize the task with the highest drop rate first. So this is usually the group task. But if you have a 30-minute reaction time task, that can be really boring. This is another example of something you would want to do first, so that if somebody's going to drop, they drop early. You can end the study early. A couple of best practices here. Definitely develop a list, and this is true for everybody, but especially important here. Develop a list of people who finish the group experiment who are not going to attrit. Some people like doing group experiments, some people don't. Some people understand the process, some people don't get it. And so what you want to do is you want to have a list of people that are going to finish to help make sure that you have groups that will go all the way through. And this is not necessarily people who are good at finishing the particular experiment that you're doing, but just people who have finished group experiments before in the past for you. The other one here is using existing groups. So classrooms are really great here because students will finish a group experiment as a part for extra credit. Also using real teams, so people who know one another, who work together already, are much more likely to finish than those who don't. And lastly, we have an ambassadors program for volunteer science, so it's basically friends recruiting friends. They're really good at finishing. Lastly, again, if you can allow replays, this is great. Because if somebody gets halfway through the group experiment and you lose the data, but you know that they made it that far, they're much more likely to continue that far later on. And they're less likely to attrit. And in this case, no matter what you do, no matter how you design it, the biggest threat is going to be post-randomization attrition bias. So people leaving a study after you randomize because of some aspect of them or some aspect of the study. And this attrition, if it happens more so in some types of conditions or for some types of people, is going to bias your data about, or bias your inferences about those kinds of people or those kinds of conditions. So you'll always want to do post-randomization attrition checks to make sure that the people didn't leave a particular experimental condition more than others. But you'll especially want to look at that in this particular study because of how much attrition you'll get. Okay, so the second set of design considerations is just the elements themselves. What are the elements of a basic group study? And we have 5. One of them is the experiment. So technically there are 4 things that you'll have to think about besides just the experiment itself. So the first one is consent. And generally the consent can be the same as your generic consent. The 2 things that you'll want to do is mention that people will be interacting with real people. And you'll want to use the phrase may be interacting. Because if you are interacting with bots, you don't want to tell them that they're real people. That's deception. Unless you have a deception study, which is its own thing. But generally, you want to say may be interacting with real people. And you'll also want to mention that you can't control what those people say or what they do. So if somebody, if you have a chat system, you'll definitely want to have this in there that says you can't control what people say. And you'll want to provide some mitigation if people say some crazy things or they threaten one another. Tell people that they have the right to report and how to report the threat. If you don't have a chat, you can say people are still likely to be mean, for use of a PG word. And so what you'll just warn people that that's the case. Sometimes you may be in a prisoner's dilemma and somebody is just mean and they're just going to defect the entire time and they won't care what you do. And that's just how the study goes. So those are the 2 things you want to make sure that you add to your consent. That you might be interacting with real people and you can't control what people say and do. The biggest issue with group studies is the instructions. And the reason here is this bold. There's no such thing as an intuitive interface. You're going to build a weird interface for people to make decisions that based on this weird information that you're giving them because we're scientists and we do weird things. And there's nothing about it that's going to be intuitive. You're going to think it's intuitive, and it's not. So, a couple of things for you to do to help people understand how to use the interface and what you're asking them to do in the study. The easiest thing to do is to do a video tutorial, exactly like I'm doing right now. I use OBS Studio to shoot these. It's free. It's relatively easy to use. I'm not a video expert. I've figured it out. Shoot a video, put it up on YouTube, and then embed that video at the beginning of your study. And what the video does is it just shows you pointing and clicking. It says, here's where you enter in the chat. Click send. Here's how you make the decision. And if you need people to certify, yes, I'm done. They just can't just make a decision, but they have to click the yes, I'm done button. You want to make sure that you demonstrate that. So the video tutorial, I think, is probably the most effective mode that you can do because it shows just pointing and clicking everything. The problem with video tutorials is that they are hard to change. So if you make a little change to your study about how the data is being entered or what they need to do, you have to reshoot a whole new video. You could, if you got good at editing, you can probably edit the individual pieces, but you have to go in and edit an entire video just to make a change to it. This is most relevant to something like a prisoner's dilemma or economic bargaining game where you might be changing the trade-off values, or a network experiment where the interface may change based on the size of or type of the network. These is where the video tutorial may become more difficult. The second kind of set of instructions are an example round. So this is actually having people play one round of the study by themselves as a practice. So again, this is effective because it gets people to practice, and it allows you to identify whether people actually are able to interact with the interface as you expect. Do they press the buttons that you need them to press? The other advantage here is that it's easy to change. Unlike a video tutorial, you can just do a quick recode and you're done. And if you are doing like these economic bargaining games and you're changing the payoff structure, or you're doing a network game and you're changing the network structure, it's easier for you to change the basic experiment and have that be reflected in the example round. The downside is that it's hard to build. This example round is basically another version of your study. It's a single player tutorial round. So it's a lot of work to build. The last one is the easy thing to do, but the least effective, and that is a text tutorial, giving people text instructions about how the study is supposed to work. If you're going to do a text tutorial, at least do an image with some circles and arrows about what people push when and how. Again, this is the least effective, but it is the easiest to change and the easiest to build. You can just write new text if you change how the study works. The last thing I want to add here is that no matter what you do, always add instructional checks. Ask people questions about how the interface is working. That way, you can either kick them out if they don't understand it or retrain them, or at least you can do some post-study assessment on whether failing the instructional checks affected the outcome. So again, the big take-home here is there's nothing intuitive. There's no such thing as an intuitive interface, and you're going to have to spend some work, time and energy thinking about how to instruct people and doing your study, for group experiments especially. The third component is the waiting room, or also called the lobby. And this is where people wait for everyone to show up for you to start the study. So the reality is people don't show up on time. No one's going to go into a study and be ready to start at noon on Friday. 10 people aren't going to show up in your study on noon on Friday. They're going to come in a couple minutes late. And so what you want to do is you want to have a waiting room so the study doesn't actually start until everybody is there and ready. Volunteer Science has a waiting room built in. I think most systems now have most systems that support multi-person studies have waiting rooms built in. There are 3 ways that you end the waiting room. One is time delimited. So as soon as the first person comes in, a timer starts, and we're going to wait 10 minutes. And as soon as that 10 minutes is up, no matter how many people are in the waiting room, we're going to start the study. That's a little bit difficult to pull off if you don't know that you're going to get 10 people in those 10 minutes. But what we do mostly with our time delimited waiting rooms is preventing people from waiting too long. We don't want people waiting 30 minutes. So at the end of 10 minutes, if there's not enough people showing up, we'll give you that one-player version of the study that I mentioned earlier, so that you at least give us some data, and you're not waiting ad infinitum for people who are not going to show up. The one that we use the most frequently, that gets the most usage, is the size delimited. So we wait until we have enough people to show up. So if we're waiting on groups of 5, we have a waiting room. It'll wait 10 minutes. So if 5 people don't show up in 10 minutes, it'll go on to a single player version. But as soon as 5 people show up, if it's 30 seconds or 2 minutes, the study is going to start as soon as that 5th person shows up. The last example, the last type of waiting room closure rule is the manual rule. This is where the researcher presses a button that says, this is done, let's start this thing. And this is most helpful for studies especially where you're working with your students or existing teams, and you just want to say, I think everybody's here, let's go ahead. Because if you have 12 students sign up for a slot, 10 may show up, but you don't know until you're sort of a couple minutes into the waiting room. But at that point, the researcher can email the students who haven't shown up to see if they're around, wait a minute or two, and then just press go. This is sort of a nice combination of the time and size limited option. The last element, besides, of course, the experiment, is the grouping. And there's 2 things that go on here. One is randomization. How do you randomize people? And can you randomize people to different group sizes? And what kinds of study conditions are you randomizing them to? And there are a lot of different randomization algorithms out there, whether flipping a coin or, of course, all of them are going to leave me right now. Balanced randomization, so you're always getting one team in condition A, one in condition B, and one in condition C, and then you randomize it again. The other aspect of grouping is matching. So if you want to make sure that people have the same background characteristics, or that that the groups are based on those who are naive or non-naive, who's getting matched together. That's the other aspect of this. Just as a side note, if you're using volunteer science, randomization happens at the end of the waiting room. So once the waiting room closes, you set the randomization there. On subject matching, what you would have to do is have all of the participants in a single study, match them up, and then send them up to a next waiting room, where everybody who's matched on naivete and non-naivety go to one waiting room, and those who are waiting, who are non-naive, go to another waiting room. Just as a parenthetical. And then, of course, the experiment. So I laid these out because there are 2 ways for you to line these up. As you can see, the experiment's always at the end. But this is sort of the process of what participants do on their way to the experiment. So this first study design pattern is the group last pattern. So this is waiting till the very end to put people into groups. So you do the consent first, you do the instructions first, the training round, the videos, then you do the grouping. So you're matching people based on naivete and randomizing, and then sending them to the waiting room, where they actually will wait together and then start the experiment. The advantage here, of course, is that you're moving the randomization and group experiment last. So what you can do here is you can have 50 people start the consent form if you need a group of 10, and you're gonna get tons of people get to the waiting room, and then you can match whomever is left at the end there and have them go into the experiment. This is what I mean by it's easy to oversubscribe. The challenge here is that you really have 2 studies. So the consent, instructions, and grouping is its own study, and then you're sending people to a waiting room and then another experiment. And so having the waiting room be far to the end means you're going to have a lot of people do the consent, instructions, and grouping and then drop. So I think you're just going to get a lot of loss after this first set of steps. In contrast, the all-in-one pattern has the waiting room up front. So people are going to aggregate into their groups, they're going to get randomized, and then you do consent instructions in the experiment. The advantage here is that everybody's doing it all together all at once. It's all one study. There's no hopping from study to study. The challenge here is that randomization happens first, and so you are more likely to get the attrition here at the end. So if you are somebody who needs this particular number of people to start your study, the group last pattern is good for you. If you're somebody who's more flexible about how many participants you can have in your study, the all-in-one pattern is good for you. Usually, this is a very generic statement. Oh, the other one is the slow participant affects everybody. People have to press, I consent. They have to read the instructions, and then they have to do the experiment. And so, when you're already in a group experiment together with another group of 50 people, for example, one slow person who's going to take the entire time to click the consent is going to slow everybody else down. And you got to wait for them to do the consent, the instructions, all that stuff. The all-in-one pattern can be a bit more annoying, especially if you have somebody who has a bad internet connection. It's not necessarily their fault that it takes forever to read. It's more that it just takes forever for them to load the study data. So if you have big groups, people who are in low connection areas, the group last pattern can actually be the more pleasing, less annoying version. But those are your two main options. Okay, so now that I laid it out, I think that you can sort of go through these slides and pick out the study design patterns that are best for you. So if you want to take a little bit, pause this video, lay that out, go ahead, and we'll move on. Feel free to unpause as we move on to the next section here. Subject recruitment. As I mentioned earlier, subject recruitment is the hardest part of doing multi-person studies. Building the study is easy. Designing the study recruitment is hard. So I have a couple of things that work. I think there are 4. And I'm going to tell you how they work. Doesn't necessarily mean they're going to work for you. So online ads requires money and funding if you don't have the funding for it. Or it's really expensive for the particular kind of subject that you're doing. It's not going to work for you. But my hope is that one of these things will work for you. And I'll show you how to do it. Or tell you how to do it. Online ads work through what we call the burst spend, which is at a high level, we spend a ton of money all at once to get a lot of people to show up very quickly. And the calculation goes like this. Say it costs 50 cents to recruit your subject. So that means $100 an hour of advertising spending is going to get you 200 subjects every hour. So this is like the 2 trains. One's going 40 miles an hour, one's going 60 miles an hour. Where are they going to meet in the middle? A little bit of algebra here. So you're getting 3 subjects per minute. If you're getting 200 subjects an hour, that's 3 subjects per minute. And if you spend $500, that's 1,000 subjects an hour, or 16 subjects per minute. So if you're doing a group experiment with 16 subjects, you have to spend $500 an hour to get 16 subjects into a waiting room within 1 minute. But that's 1,000 subjects in an hour. So you're doing pretty well, I think, in terms of cost. Again, this is all under the assumption that it costs 50 cents to recruit a subject. How does this work? How do you actually use the burst spend? The first thing you're going to do is you're going to create test ads with a one-player version of your study. And you're going to run those ads to see how much it costs to get people to actually complete that study. And it's also good for test data. Again, this is one of the reasons why you would want a one-player version of your study. You calculate how much it costs, and then you do the math. How many groups do you need? What's the size of each group, and how much time do you want them to spend waiting in the waiting room? And so you fill in the calculation there. Once you have your calculations, do a small burst, just to test. If I actually spend $500 in an hour, am I going to get 16 subjects in the first 10 minutes? So you do your small burst. Once you validate that works, then you go ahead and scale up and do your big burst. So here's a sort of fully worked out example. So you need 100 groups of 10, and they're going to wait 1 minute. And it costs $2 a participant. So it's actually pretty expensive, $2 per person to have them for 100 groups of 10 waiting a minute. So if they're waiting 1 minute for a group of 10, that means you need 10 people every minute. And that means you need to spend and it's $2 per participant, so you need to spend $20 every minute, which equals $1,200 an hour in order to get groups every minute. So that means it's going to, so if you need 100 groups and you're doing 1 group a minute, that means it's 100 minutes to do all of your groups. So $1,200 an hour over 100 minutes is an hour and 40 minutes. So $1,200 an hour for an hour and 40 minutes is $2,000 in total. So that's, I mean, if you have funding, this is usually not that big of a budget for subject recruitment. I think if you're doing Mechanical Turk, usually we get an average of about $15 per person. So this is a very reasonable cost for groups of 10. So this is how the online ads system works. Again, what you'll want to do is test and develop early, figure out how much it's going to cost for your study, and then do the math and figure out if it's reasonable. Okay, Mechanical Turk. Sorry, I'll mention one of the disadvantages of online ads is you can get high attrition. So if you have a flexible study, this is good for that. If you have an inflexible study, this is going to be less good for that. The other advantage here is that it's usually cheaper per participant than in something like a Mechanical Turk. You're not paying the Mechanical Turk overhead, but again, you get more attrition. And there's also sort of a risk here in that you're spending $1,200 an hour, and after 30 minutes, you don't get people showing up. You've lost $600. So it's a bit more risky than something like a Mechanical Turk. So Mechanical Turk works like this, the way we do it, and that's batching hits. I should mention scheduling. Scheduling is also possible. I'll mention that. So burst batching hits means you launch your hits in batches, and you add new batches as groups finish. So, for example, if you need groups of 5, you'll launch batches of 15. Something as small as 5, I would launch batches of 25 or 30 because it's not that big. But if you're doing groups of 20, you'll definitely want to launch about 60 hits to get 20 people to show up immediately and get into the waiting room. The great thing with Mechanical Turk is they have a big pool of people. A lot of them will start taking your hit immediately. But there are a lot of people in Mechanical Turk who will reserve a hit. They'll take the hit, but they'll put it in their queue, and they'll get to it when they're done with their current hit or the next 10 hits that they want to do, which is fine. They'll show up in 30 minutes. In 30 minutes, you'll probably still be looking for new subjects, but you need people to start within the first 5 minutes. So that's why we say 2 to 3 times the size of the group you need. The other thing I will note, to go back to the scheduling bit, is what you can do is you can have Turkers come in and they do a 50-cent hit where they put in the demographics and then they sign up for a time to do the hit, to do the group experiment. So let's say Thursday at 2. And then you send them a little note through the Mechanical Turk communication system the day before or the morning of, and you say, hey, don't forget we have this $5 hit, $10 hit for you today at 2 that you signed up for. And then you run the people who signed up for that time at that time. That's a bit more efficient, but it still can be tough. So in general, the attrition rate of Mechanical Turk is 20%, so 1 in 5. I don't know to what extent it varies between batching versus scheduling, the burst batch or schedule, but it's relatively high. So 20% attrition means that if you were doing groups of 5, then half of your groups will experience at least 1 drop. So if you have one of these hard studies where you can't tolerate drops, and if it's a group of 5, you're going to throw out half of your data, or at least half your groups are not going to be complete. So this is the downside of Mechanical Turk, is that it's a pretty high attrition rate. The problem with Mechanical Turk with the attrition rate is not only that you lose your data, but you still have to pay the people who participated, who made it as far as they did until this first person dropped. And so the best practice here, one, is you end the hit as soon as possible if you have a hard design. If you can't continue with the study, just end it. Don't waste people's time, let the Turkers go on and earn pay elsewhere. Definitely pay everyone who participates, and include how much time you ask them to spend in the waiting room as part of your payment calculations. If you're gonna ask people to wait for 30 minutes in your waiting room, you should pay them for waiting for 30 minutes. Related to this, create the time to limit waiting room and one-player study, so somebody doesn't wait 30 minutes, because if they do, you should pay them 30 minutes worth of time. But who has a budget to pay for somebody to just wait for 30 minutes? So again, I think we usually do 10 minutes of waiting, and then if somebody doesn't show up, the Turker will do a one-player version, and we pay them for the one-player version. Lastly, create qualifications for people who complete the group stage. There's just Turkers who like it, some people don't. So qualify people who do complete the group part of the study and invite them to your future group hits, group experiments. The next thing is the ambassadors. So this is a volunteer science specific program that we've created, but you can do the same thing. Again, I think I sort of threw this out earlier, but the ambassador program is friends recruiting their friends to participate together. The way this works is that we recruit and train an ambassador on a particular study. We say, this is how the study works. This is sort of the steps, how long it's going to take, and what the interface should look like, and some common questions that may come up. And we also train them on how to debug. So if something comes up, we tell them, take a screenshot, open up the developer console, and send us all of that stuff. So they learn how to do some remote debugging too. So the ambassador gets trained, and then they recruit their friends. They schedule a time with their friends to participate, particularly for group experiments. If it's a one-person study, then they don't need to schedule a time. But the ambassador will do the scheduling and coordination. But they check in with us so that we're able to help them coordinate a time. And lastly, when the time comes, people participate, we pay the ambassadors per person who completes. And this payment can vary from $1 a person for doing a survey or a 5 minutes 2-person experiment to up to $10 per person who completes if it's a really large group for a long period of time, like 10 people over an hour will be $10 a person, or 50 people an hour would be $10 a person. The advantage for the ambassador program, if you're recruiting friends who are recruiting friends, is that there's a very low attrition rate. Friends don't want to disappoint their friends. Generally, the attrition rate is all driven by study error. When something goes wrong with the code that we didn't expect, or somebody loses an internet connection. It's almost never because somebody gets tired of the study. Now, we don't run very obnoxious studies, so we're not pushing anybody out. But generally, if you're doing a standard group experiment, you're going to get a low attrition rate with ambassadors. The other advantage to ambassadors is that they're really good for error reporting and troubleshooting. Again, they don't want their friends to have bad times, and when their friends have an error, they want help, and they come to us. They'll do their error reporting. We fix it for them. Everyone's okay. If you're running Turkers, Turkers will complain, but they won't error report. And they're not trained to error report. They don't know your system. Amazon makes it really difficult for them to report bugs because of the way that they use iframes. And so it's a really good way for you to do error reporting and troubleshooting. The other part of this is that it's really good for large, super large group studies, so up to 100. The way we do this is we have ambassadors recruit their local friends, and then we have 5 ambassadors who've done their friend recruitment, and then we coordinate them to work at to do their events at the same time, say 3 p.m. Eastern, so it's 7 p.m. London time or 8 p.m. London time, and noon on the West Coast. So we have the entire afternoon here on the Western Hemisphere. So they're really good for these kinds of large groups. The disadvantage, of course, is that it's expensive. Up to $10 a person can be pretty expensive for large groups, on top of some management costs that we charge. Again, you can do it yourself, but you'll still be paying a lot per person. And it's also time consuming. So you got to train, you got to recruit, you got to schedule. So there's a lot of that time overhead coordinating with ambassadors. But again, if you're doing large groups with low attrition rates, ambassadors are exactly what you want. Lastly, classrooms, campuses, partners. So this is for those of you who have zero funding and need to do group experiments. And this is why you see this a lot, especially in business schools. People using master MBA students in classrooms because it's hard to get funding. And all you need to do is show up at a faculty member's classroom and say, "Hey, can I get your intro accounting class of 300 students to participate in the study?" And you're done, right? If you need groups of 3 in a 300-person classroom, that's 100 groups in the course of 20 minutes at the beginning of class. So I will never knock classroom experiments for that reason. So there are 2 options here. One is you do it during class. You do it during an organizational event. the organization has an all hands call, or um, they set aside time for professional development. You organize it during that event. Um, Option two is to have those students, those teams, those people actually sign up for a time, and for extra credit or for some sort of recognition, they participate in your experiment. And if you have people sign up, always oversubscribe. If you have groups of 10, have 15 people sign up. Uh, and then if they show up, tell them thank you. You'll get extra credit anyway, but we don't need you. The advantages here, it can be done for free. This is the real advantage. If you don't have any funding, this is the way to do it. You also get pretty low attrition. Students will hang out for extra credit. And if you're doing it at an organizational event, they got to be there anyway. So the attrition is pretty low. The disadvantage is you get a narrow sample. So tons of studies on MBA students may not tell us very much about the bargaining strategies of your everyday person. It's lots of time and effort. So you do have to go out and convince a faculty member to run your study in their class, or reach out to organizations and develop a partnership. So this is a good example of trading money for time. Lastly, the participants can know one another. Whether in a classroom or an organization, you may not have a completely novel group that you're working with. You can do some mixing and matching around that. And again, this is a part of your grouping process, but it may be more challenging. I will say with the ambassadors, they also very well may know one another, but we can control that. And you can control that by having them scheduled at the same time. So you have ambassadors in locations A and B scheduled at the same time to participate. They all log on. They don't know who they're participating with, whether it's somebody from A or somebody from B. All right, that's it. I want to give you a little bit of time to think about your recruitment plans, what you think will be best for you. Come up with options A, B, and C for how you would want to recruit for your study, and how it fits into the particular kind of design that you have, whether it's a hard design or a easier, more scalable design. All right, thank you so much. Again, last final reminder that in 2 weeks we'll do a build your own subject pool workshop. That you can sign up with that on our website. If you have any questions or want to see anything in the future on these workshops, please email me at jason_radford@volunteerscience.com. And lastly, tell us what you'd like to see in trainings these fall at our All Our Ideas page, allarideas.org/vs-trainings. All right. Thank you so much, and enjoy your week.